right, so the next lesson is on slopes of parallel and perpendicular lines. All right, so first thing I want to just go over what parallel and perpendicular mean. So the two lines are parallel when they never cross. So if I have one line like this, and in geometry, the way they signify is two arrows. But anyways, if I have two lines that are the same direction, have the same steepness, um, then they are parallel. Direction, steepness. So since slopes are so the slope of a line gives you the direction and the steepness of the line, it kind of makes sense that two lines are parallel if they have the same slope. So if the slopes of two lines are equal, then they are parallel. All right, next up, perpendicular lines are lines that meet at 90 degrees. So if I have a line, that's my first line. If I draw another line this direction, then the way they indicate is they draw a square there. Okay, this means that they meet at 90 degrees. I can draw a line through there. So as long as they meet at 90 degrees, they're what they call perpendicular, right? So the slopes of perpendicular lines are what they call negative reciprocals. So negative reciprocals, example, would be, let's say I have a 2 over 3. Negative reciprocal of that one. Reciprocal means to flip fraction. So that would be 3, 2. However, it's going to be a negative 3 over 2. So these would be what they call negative reciprocals because you're doing two things. You're flipping the fraction and you're changing the sign. So another example of, let's say, negative reciprocals is if I have, let's say, negative 4. Well, the negative reciprocal of that would be positive 1. So since this is the same as negative 4 over. Right, so any number itself, right, you're going to write it as over 1. And to get the reciprocal, it's going to be 1 over that number. Right? And again, we're dealing with negative reciprocals. So if one number is negative, the other one's got to be positive, and vice versa. Okay, so that's the concept of negative reciprocals. All right, so if I know the slope of one line is, for example, 2 over 3, the slope of another line is negative 3 over 2, then I can conclude that those lines are what they call perpendicular, but they will meet at 90 degrees. So yeah, let's do a couple examples, and hopefully this kind of solidifies it, this concept. All right, so line ST passes through the S, the point. Line UV passes through the point B. All right, so are these two lines parallel, perpendicular, or not? All right, so to determine whether these two lines are parallel, perpendicular, or neither, what I need to do here is to calculate slope of the slopes line. All right, so for instance, the slope of, call it ST. If you remember the slope formula from the previous 2 lessons ago, basically what you do is you subtract the y values. So because y1 minus y2 or x1 minus x2. Or y2 over y1. Sorry, y2 minus y1 over x2 minus x1. These are interchangeable. Whether I call one point the first point, the other one the second point, or vice versa, it actually doesn't matter. I showed you that in the right. So anyways, it doesn't matter which point you choose as your second point, just as long as here that the points line up, right? So notice here I got x1, y1, x2, y2. over here in the form y2, x2, y1, x1. Right, so just the points have to match up. All right, so let's calculate the slope of ST. So my point S is negative 2, 7. So the y value here, y1 we'll call it 7. There I need to subtract negative over. My x value here was negative 2 minus my second x value here was. So if I plug in S and T into the slope formula, I have again 7 minus negative 5 over negative 2. Right, so this here, two negatives make a positive, so this is the same as 7 plus 5, which is 12. On the bottom here, I have negative 2 minus 2, which is negative. And this I can simplify, so 12 divided by negative 4 is negative. So the slope of ST is going to equal negative 3. All right, so that was the first line there. Let's calculate the slope of the other line of U. So again, I'm going to subtract the y values. So 3 minus 6 over negative 2 minus 7. Okay, so if I work this out, 3 minus 6 is negative 3. Negative 2 minus 7 is negative 9. Now this fraction reduces to positive 1. All right, so that's the slope of UV. And now if we compare two slopes, see that they are negative reciprocals, right? Negative 3 here, and I have positive 1. That means that these two lines are perpendicular. So since they are negative reciprocals. Now, just to kind of illustrate the point, or let's visualize. What I did is I put a grid up here. So I'm just going to plot the two lines and see that they do actually get 90 degrees. So the point S, negative 2, 7. S, negative 2, 7. T was 2, negative 5. All right, so if I plot those 2 points, negative 2, 7, there, point S, 2, negative 5, at this point T. So we're trying to freehand this a bit, just to be in a straight line, but anyways, I'm gonna. Oh, I think that one's a little better. All right, so there's ST, and the point U, negative 2, 3, and V was 7, 6. All right, so when I plot those 2 points, negative 2. All right, so negative 2, 3, and 7, 6. Those. So again, this is V. We concluded that was 90 degrees, and you know what? It does kind of look like. All right, so I know I kind of freehanded it, but it appears to be 90 degrees as well. So therefore, those two line segments are perpendicular. But we know that they are actually absolutely perpendicular because two slopes were negative reciprocals. All right, so I got another example here. This time we're given some points, but we're missing one coordinate. All right, so point A is 1, 4, B is 5, 1, C is 6, 3, D is 2, and then this A here, what we're going to determine the value of for each one of these conditions. All right, so given these, we'll call it 3.5 points. Determine the value of A for which the line AB is parallel to CD. Okay, so In order to do this, what we want to do first is we want to find the slope. So if I can find the slope of AB, then I know that the slope of CD must be the same. Then I'm going to show you how to work the equation to solve for this variable. All right, so first step here, let's find the slope of AB. Again, I'm going to subtract my y values, so I'm going to go minus 1, 1 minus 5. All right, so if we work this out, we get 4 minus 1, which is 3. 1 minus 5 is negative 4. So that's the slope of AB. Now, in order to be parallel, the line CD must have the same slope. So we know that the slope of CD is also 3 over negative 4, or negative 3 over 4. Well, if I so one side of this equation I'm going to set as negative 3 over 4 because I know that's what slope of CD must be. All right. Now on the other side here, I'm actually going to use the slope formula, which was y1 minus y2 over x1 minus x2. And what I'm going to do here is I'm just going to plug in these values here. So the y1 we'll call it 3, y2 we'll call A. And then we have the x value, which is 6, 2. So we actually, what we've done here is we've created an equation with one variable that we can solve for here, which is A. So again, this is the slope that it has to be because it's going to be equal to the slope of AB because it's parallel. This over on the right-hand side is using this formula and plugging in these values here with the variable. All right, so to solve for A here, I'm just going to simplify this a little. First step here, 6 minus 2, which is now to solve for A, we can cross multiply. Or we can actually, you know what, we can multiply both sides by 4 and the 4's cancel. But anyways, I'm gonna cross multiply because I started it. But either way, we're gonna get the same answer. So this means that 4 times 3 minus A is going to equal negative 3 times 4. All right, so if I expand out these brackets here, I get 12 minus 4A equals negative 12. So, all right. All right, so to solve for A, this 12 needs to get moved over the side, so that's minus 2. So I'm just going to continue it over. So on the right-hand side, negative 12 minus 12 is negative. And I still have the negative. And the final step here is to divide both sides by negative 4. Therefore, the value of A here equal to negative 6. Right? Okay, so you know what I'm going to do here? Just this little take. Cut this out, the grid here, and paste it in there. Yeah. Then we'll do part B, perpendicular. But anyways, before I do go on to part B, I just want to draw and show you the situation here. All right, so line AB was from 1, 4 to 5, 1. So I'm going to plot those two. So 1, 4 there, 5, 1 is there. So this is point A, B. So this is the line segment AB. And then point C was 6, 3. 6, 3 is like right. So that's point C. And then what we wanted to do is we wanted to find point D, which the x coordinate was 2. 2. So, and we found that the A value is negative 6. 2, negative 6. 6. Oh, look, Oh, I just found it. I was not gonna lie, guys. I was a little bit worried. I thought I would have to do everything over. It's one slight mistake. Negative 24 divided by negative 4 is 6. Not. Right. So obviously. Okay. So the point D here is going to be at 2, positive 6. So let's plot that. So 2, positive 6 is right here. Positive 6 there. That's point D. So now if I connect these two together, you can see that the lines do appear to be parallel. All right. Yeah, those. Okay, so negative 24 divided by negative 4, positive 6. All right, so the value for A there would be 6. See that these two lines appear to be, they'll indicate with arrows there. Okay. All right, now part B. Line AB is perpendicular to CD. So this time we want to find a perpendicular line. So we found in the first step here that this, or part A there, the slope of AB is equal to negative 4 over 3. Negative 3 over 4. Okay, so we found that the slope of AB is negative 3 over 4. So in this case, since it's perpendicular, then we know that the slope CD must equal positive, right? The opposite's negative reciprocal here. So since that one's negative, this slope's got to be positive, and it's positive 4 over. Right. Now I'm going to do the same thing here. I'm going to plug in points CD into the slope formula. So 3 minus A over, forgive me, I just got to keep scrolling back and forth. My x values, which were 6 minus 2. All right, so again, I want to solve for A here. So first step I'm going to do is do the 6 minus 2, which is 4. All right, so this time again, to solve for A, I'm going to cross multiply. So 4 times 4 on the side is going to equal 3 times 3. And let's solve for A. So on this side, 4 times 4 is 16. Now on this side here, I'm going to expand out the brackets here. So I got 9 minus 3A. Next, going to move the 9 over, so that's minus 9. 16 minus 9 is 7. I have negative 3A. So last step here, just going to divide both sides by negative 3. So as a result, these cancel, that A is going to equal negative 7 over 3. Now, yeah, so this would be the answer for A. Now, when I want to visualize this and test it as on the grid here, I'm just going to write it as a decimal. So negative 7 over 3 is 7 divided by 3, which is negative 2. This one, please. Negative 2.3. All right, so let's plot this and see what happens. So again, my point C is still the same here. Now point D is going to be at 2, negative 2.3. So where's that? 2, negative 2.3. So draw it in green. So this time, so this is the answer for part B. If I connect this point here to point C, too bad. You can see that, yes, it does meet the line. It does appear to be 90 degrees. So, so yeah, so that's the way you would value of A. All right, guys. Cool. So that is parallel and perpendicular.